National Electrical Code Section 450.11b states where disconnecting means for two or more motors are grouped together, there shall be a single disconnecting means for all of the motors as provided in Burner B2. National Electrical Code Section 450.11 burns separate disconnecting means for each motor shall be provided when the motors drive separate pieces of driven machinery. National Electrical Code Section 450.11b2 group operation of the motors shall be permitted where they are interdependent for a specific purpose, such as simultaneous starting of a group of motors to provide the required starting torque for a particular machine. National Electrical Code Section 430.20 states motor controllers and disconnecting means shall be permitted to be located in the same enclosure with the motor. Based on National Electrical Code Section 450.11b, a single disconnecting means for both motors is permitted since they are operating as a group for a specific purpose, such as speed control. National Electrical Code Section 430.2 allows the motor controllers, which in this case are inverters, to be located in the same enclosure with the motors. It appears to be permissible to feed the Hoffman enclosure from two separate disconnects in the motor control center panel, as long as certain requirements are met. Firstly, the enclosure needs to be properly labeled, indicating that it contains multiple disconnecting means. Secondly, the disconnecting means should be accessible without removing any covers or panels. Thirdly, the disconnecting means need to be clearly identified for each motor. An engineer may have concerns about the potential for electrical fault currents to flow through the enclosure if one of the motors is disconnected. To mitigate this risk, install a fault barrier or other protective measures within the enclosure. Consult with a qualified electrician to ensure that the installation meets all applicable codes and standards. The information provided is based on the National Electrical Code and standard electrical engineering practices. It is always recommended to consult with a qualified professional for specific applications and to ensure compliance with local codes and regulations. Understanding the requirements for disconnecting means is crucial for ensuring the safety and proper operation of electrical systems, especially when dealing with multiple motors and control equipment. Consider the scenario where you have two identical motors powering a conveyor system. These motors need to start and stop simultaneously to ensure the smooth operation of the conveyor belt. According to National Electrical Code Section 450.11b2, a group operation of the motors is permitted since they are interdependent for a specific purpose. This means that you can have a single disconnecting means for both motors, simplifying the control and safety aspects of the system. However, if these motors were driving separate sections of the conveyor system, each with its own independent function, National Electrical Code Section 450.11b would require separate disconnecting means for each motor. This ensures that each section of the conveyor can be independently isolated for maintenance or troubleshooting purposes. Proper labeling and identification are essential for maintaining a safe and efficient electrical system. All disconnecting means should be clearly labeled to indicate which motor or piece of equipment they control. This helps prevent accidental shutdowns or startups, which could damage equipment or injure personnel. Accessibility is another critical factor to consider. Disconnecting means should be readily accessible without having to remove any covers or panels. This allows for quick and easy isolation of equipment in case of an emergency or during maintenance procedures. In addition to the National Electrical Code requirements, it is important to consider other factors such as the size and type of conductors used to feed the motors and inverters. The conductors should be sized appropriately to handle the full load current of the motors, as well as any potential fault currents. Overcurrent protection devices, such as circuit breakers or fuses, should be installed to protect the conductors and equipment from damage due to overloads or short circuits. When installing inverters for speed control, it is important to ensure that they are properly grounded to prevent electrical noise and interference. Grounding also helps to protect against electric shock hazards. The inverter should be installed in a location that is free from moisture, dust, and other contaminants. They should also be adequately ventilated to prevent overheating. Before starting any electrical work, it is essential to energize the circuit and verify that it is safe to work on. Use a voltage tester to confirm that the circuit is de-energized before touching any wires or components. Always follow proper lockout-tagout procedures to prevent accidental re-energization of the circuit while you are working on it. When working with electrical equipment, it is important to wear appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. This will help to protect you from electric shock, burns, and other injuries. If you are not comfortable working with electrical equipment, it is best to hire a qualified electrician to do the work for you. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent accidents. In conclusion, understanding the National Electrical Code requirements for disconnecting means and motor control is essential for ensuring the safety and proper operation of electrical systems. By following these guidelines and consulting with a qualified professional, you can create a safe and efficient electrical system that meets all applicable codes and standards. Remember that the National Electrical Code is a complex document, and it is important to stay up to date on the latest revisions and interpretations. Regularly review the National Electrical Code and attend training courses to enhance your knowledge and skills in electrical safety and installation practices. Applying these principles will aid in the correct and safe installation of motor controls. For instance, if the two motors are part of a system that requires coordinated control to perform a single task, like a material handling system where one motor feeds material to the other, then using a group disconnect would be appropriate as per National Electrical Code section 450.11b2. This ensures that the entire system can be energized with a single action, which is safer for maintenance and troubleshooting. Conversely, if one motor operates a cooling fan and the other drives a pump, and each can operate independently, separate disconnects would be necessary, complying with National Electrical Code section 450.11b. Each component can then be isolated without affecting the other, allowing for targeted maintenance. The electrical enclosure housing, the inverters, and other control equipment needs to be selected based on the environmental conditions of its location. If the location is prone to moisture or dust, an M4 or 4X rated enclosure should be used to protect the components inside. Proper ventilation is also critical to prevent overheating, which can damage the inverters and reduce their lifespan. Consider using thermostatically controlled fans or air conditioners to maintain the enclosure temperature within the recommended range. The wiring inside the enclosure needs to be neatly organized and properly labeled. Use wire ducts and cable ties to keep the wires bundled together and prevent them from interfering with each other. Each wire should be labeled with its function and destination to facilitate troubleshooting and maintenance. The grounding system is another important aspect to consider. The enclosure and all the components inside should be properly grounded to provide a low impedance path for fault currents. This helps to protect against electric shock hazards and prevent equipment damage. Use a dedicated grounding conductor and ensure that all connections are clean and tight. It is also important to consider the available fault current at the point of connection to the motor control center. The components inside the enclosure, such as circuit breakers and fuses, need to be rated to withstand the available fault current. A short circuit study should be performed to determine the available fault current and ensure that the components are adequately rated. If the available fault current is too high, current limiting devices may need to be installed to protect the equipment. When selecting circuit breakers or fuses, it is important to consider the motor's starting current. Motors can draw a large amount of current when they are first started, which can trip the circuit breaker or blow the fuse if it is not sized properly. Use a circuit breaker or fuse that is specifically designed for motor starting applications and size it according to the motor manufacturer's recommendations. Another consideration is the harmonic content of the current drawn by the inverters. Inverters can generate harmonics which are unwanted frequencies that can cause problems with other electrical equipment. Install harmonic filters to reduce the harmonic content of the current and prevent these problems. The harmonic filters should be sized according to the inverter manufacturer's recommendations. Surge protection is also important to consider, especially if the equipment is located in an area that is prone to lightning strikes or other voltage surges. Install surge protection devices to protect the equipment from damage due to voltage surges. The surge protection devices should be installed at the point of connection to the motor control center and at the input to the inverters. When selecting surge protection devices, it is important to consider the voltage rating, the surge current rating, and the protection level. The voltage rating should be equal to or greater than the system voltage. The surge current rating should be high enough to withstand the expected surge currents. The protection level should be low enough to protect the equipment from damage. It is also important to consider the coordination of the overcurrent protection devices. The circuit breakers or fuses should be coordinated so that the smallest overcurrent device trips first, minimizing the impact on the rest of the system. A coordination study should be performed to ensure that the overcurrent devices are properly coordinated. When performing a coordination study, it is important to consider the time current characteristics of the overcurrent devices. The time current characteristic is a graph that shows the amount of time it takes for the overcurrent device to trip at different current levels. The overcurrent devices should be selected so that their time current characteristics are coordinated. Finally, it is important to document all of the electrical work that is performed. Keep a record of the circuit breaker sizes, wire sizes, grounding connections, and other important information. This documentation will be helpful for troubleshooting and maintenance in the future. In summary, when installing inverters and other motor control equipment, it is important to consider all of the relevant factors, including the National Electrical Code requirements, the environmental conditions, the available fault current, the motor starting current, the harmonic content, the surge protection, and the coordination of the overcurrent protection devices. By carefully considering all of these factors, you can create a safe and efficient electrical system that meets all applicable codes and standards. Always consult with a qualified electrician to ensure that the installation is performed correctly and safely. The size of the conductors feeding the enclosure must be adequate for the total load. Calculate the total current draw of both motors, including any additional loads within the enclosure, and select conductors that are rated for at least 125% of that value, as per National Electrical Code guidelines for motor circuits. This provides a safety margin and helps prevent overheating. The type of conductor used should also be appropriate for the environment. THHN or THWN conductors are commonly used in dry locations, while XHHW conductors are suitable for wet locations. The conductor should be installed in conduit to provide mechanical protection and prevent damage. The conduit should be sized appropriately for the number and size of conductors it contains. Another important consideration is the voltage drop across the conductors. Voltage drop can reduce the performance of the motors and cause them to overheat. Calculate the voltage drop using the conductor size, length, and current draw, and ensure that it is within acceptable limits. If the voltage drop is too high, use larger conductors or install a voltage booster. The motor control center disconnects must be readily accessible. This means that they should be located in a place where they can be easily reached in case of an emergency. The disconnect should be clearly labeled so that they can be quickly identified. The area around the disconnect should be kept clear of obstructions to allow for easy access. In addition to the National Electrical Code requirements, there may be local codes or regulations that apply to the installation. Check with the local authorities to ensure that the installation complies with all applicable codes and regulations. The engineer's concerns about fault currents flowing through the enclosure are valid. If a fault occurs in one of the motors or inverters, the fault current could flow through the enclosure and cause damage or injury. To mitigate this risk, consider installing a separate ground bus inside the enclosure and connecting all of the equipment grounds to this bus. This will provide a low impedance path for fault currents and help to protect the equipment and personnel. Another option is to use a fault current limiting device, such as a current limiting fuse or circuit breaker. These devices are designed to quickly interrupt the fault current and prevent it from reaching a dangerous level. The fault current limiting device should be sized according to the available fault current and the equipment ratings. It is also important to consider the arc flash hazard when working with electrical equipment. Arc flash is a dangerous phenomenon that can occur when there is a short circuit or other electrical fault. The arc flash can generate intense heat and light which can cause serious burns or other injuries. Perform an arc flash hazard analysis to determine the potential arc flash hazard at the motor control center and inside the enclosure. The analysis should consider the available fault current, the clearing time of the overcurrent devices, and the working distance. Based on the results of the analysis, select appropriate personal protective equipment, such as arc-rated clothing, gloves, and face shields. Install warning labels to alert personnel to the potential arc flash hazard. Another thing to consider is the use of surge arresters. Surge arresters are designed to protect electrical equipment from voltage surges caused by lightning or other transient events. These surges can damage or destroy sensitive electronic components, such as the inverters. Install surge arresters at the input to the enclosure to protect the equipment inside. The surge arrestor should be sized according to the voltage rating of the equipment and the expected surge current. It is also important to consider the ambient temperature inside the enclosure. The inverters and other electronic components are sensitive to temperature and can fail if they are operated outside of their recommended temperature range. Provide adequate ventilation to keep the temperature inside the enclosure within acceptable limits. Consider using a thermostatically controlled fan or air conditioner to maintain the temperature. Also consider the altitude. If the equipment is installed at a high altitude, the air is thinner and the cooling effect of the ventilation system may be reduced. Consult the manufacturer's specifications to determine if any dirting is required for high altitude operation. Another aspect is electromagnetic compatibility. The inverters can generate electromagnetic interference which can disrupt the operation of other electronic equipment. Use shielded cables and filters to minimize electromagnetic interference. The shielded cables should be properly grounded to provide effective shielding. It's essential to implement a regular maintenance program for the motor control system. This program should include periodic inspections, testing, and cleaning. Check the wiring connections for tightness and corrosion. Test the overcurrent protection devices to ensure that they are functioning properly. Clean the inside of the enclosure to remove dust and debris. A well-maintained system is more reliable and less likely to experience problems. Remember, safety is paramount when working with electrical equipment. Always follow safe work practices and use appropriate personal protective equipment. If you are not qualified to perform the work, hire a qualified electrician. It is always better to be safe than sorry. Remember to consult the manufacturer's instructions for all of the equipment being installed. The manufacturer's instructions provide detailed information about the installation, operation, and maintenance of the equipment. Following the manufacturer's instructions will help to ensure that the equipment is installed correctly and that it operates safely and reliably. Finally, remember to keep accurate records of all of the electrical work that is performed. These records should include the date of the work, the name of the person who performed the work, a description of the work that was performed, and a list of the materials that were used. These records will be helpful for troubleshooting and maintenance in the future. By following these guidelines, one can install and maintain a safe and efficient motor control system. Electrical work should always be performed by qualified individuals who understand the applicable codes and standards. Ignoring or circumventing these standards can lead to serious consequences, including equipment damage, personal injury, or even death. If there is any doubt about the proper way to perform the work, consult with a qualified electrician or electrical engineer. They can provide expert guidance and help to ensure that the work is performed safely and correctly. Always err on the side of safety when working with electricity.